Hello. Here we have an example of IP address, and it's a continuation of what we've been covering. That is chapter 11. So we have an example here. So let's assume that we have an address like this 192.168.20.0/29. What does this mean? That we're going to deal with this, because in subnetting most of the time we need, not most of the time, but we need to deal with subnet mask. Now we have our prefix, which is a slash notation 29. So simply 29, it means in subnet mask it's 1 2 3 4 5 6 7 8 1 2 3. Yeah, so these are 24. To total to 29, we need 5. Like this, then 3 like this. So this 29, it means this. So if I were to write the subnet mask in decimal number, so this one here would be 255, 255, 255. Then this one here, it's 128, 128.64, giving us 192. So 192, if you add 32, 32, you get 224. If you add 16, you get 240. If you add 8, you get 248. So this is our in decimal, the subnet mask in decimal format. Okay, so once we have this here, subnet mask in binary format, then we'll be good to answer this, to use these formulas. Number of subnets is equal to 2 power, I don't remember the thing, but I think it was P, the P bold bits. And I remember saying that the bold bits are those bits that are, the bold bits are those network bits that are in an octant boundary. Now, our octant boundary, it is this one here. The octant boundary, it's that octant that you're trying to segment or to divide. So the network bits in that octant boundary, there are 5. So it will be 2 power 5, giving us 2. So with this subnet mask, we will be able to actually have 32 different IP, 32 different subnet masks, 32 different groups that we have to maintain 192.168.20. But this range whereby it ranges from 0 up to 255, that we shall actually be able to come up with 32 different, 32 different subnets or different groupings. That is what it means. So now that we have different networks, 32 different subnets, how many IP addresses are going to be in per subnet? So the formula, it is number of usable addresses is equal to 2 power x minus 2. X here, these are host bits. So it will be 2. The host bits, how many? We have 3. So it will be 2 power 3 minus 2. This gives us 8. You subtract 2 and then you remain with 6 addresses, usable addresses. So meaning that per group we expect 6 usable IP addresses. And with this, it will actually, and actually in all the 32 groups, in all 32 groups. Then now we need the magic number, because the magic number, it helps us to know the range, like the difference per group, per group. So magic number is equal to 2, use the M, and then the M, these are host bits in an octet, the octet boundary. So it will be 2, the host bits in an octet boundary. Our octet boundary is this. Host bits in an octet boundary. So there are these ones here. These are the host bits in an octet boundary. The borrowed bits, the borrowed bits in an octet boundary, there are these ones. These are borrowed bits in an octet boundary. So here you're looking for the subnet mask, sorry, the number of subnets. Then on this we are looking for the magic number here. Host borrowed bits in an octet boundary. Then the magic number, it's the host bits in an octet boundary. Okay, so here it's 2 power 3, and then this gives us 8. So now if we want to list the network addresses to be the subnet list of subnets, we can actually have, so here the subnets, they have to total to from 1, 2 up to 30, 32. So I'm giving you this as also as an assignment, so that you can come up with those addresses. So this is 3, 4, and then up to 32. And I need all of them. Get a book and write those subnets. Get a book and write those subnets. So the first subnet here, it will be 192.168.20.0. Now, if I need the next subnet, then I will use the magic number. The magic number is 8, so I will add 8 on this. So the second one will be 192.168.20, then .h. Add 8 again here. 192.168.20.16. Again, 192.168.20.24. So please continue up to the 22nd subnet. So here we need the range. The first address, then the last address, then the broadcast. The broadcast. So if I want the broadcast to this side, of course, that the broadcast for this one here, I will just subtract 123. The IP address before this one here, it will be the broadcast this side, since it's going to be the continuation. So I will subtract this, it will be 192 168.20.23. So if I want the subnet broadcast for this one here, I will subtract the one here and remain with 15. 192.168.20, then dot 15. If I want the broadcast here, I will just subtract here 192.168.20, then dot 7. So you subtract the one here again, it will be a dot 6. Here, if I subtract one, it will be a dot 14. If I subtract one, it will be 22. So if I add the one here, it will be 192.168.20.1. So if I add one here, it will be a dot 9. If I add the one here, it will be dot 17. Even here, if I add the one, it will be dot 25, like that. This is what I want you to do for the entire network, but you make sure you fill these gaps, because me here was writing the last number. Just writing the last octet, but it's supposed to be 192.168.20.9, like this, even this side, 192.168.20. that. So let's you can go through this. It's as one of the example. Yeah, as one of the example. Try this. Use this knowledge. Yeah, use this. So more examples are coming. Let me just for this recording, I'm stopping here.